Hi students, this is Muhammad Ali. I'm glad to be your instructor for this course. We will use the university physics with modern physics, the 15th edition. Okay, we will start with the chapter number 1, which is units, physical quantities and vectors. To know more about the nature of physics and how the physics is developed during the years, and also how to solve the physics problems, you can see good videos on Canvas. I put them on the blog for the first lecture, and for the solving physics problems we will deal with many problems and examples in the future, and you will be more comfortable with these regimes. And we will start now with standards and units in physics, which is in page number 3. In physics we have, or we need to deal with different quantities: the mass, the speed, the force. All of these things are quantities. For example, we need to know at first that we have two kinds of quantities: fundamental quantities and derived quantities. We have 7 fundamental quantities, just 7 fundamental quantities in physics, which are the length, the mass, and the time, the electric current, which is in ampere, temperature, which is in Kelvin, not Fahrenheit, it is in Kelvin, the amount of matter, which is in mole, the luminosity, which is in the candela. The first 3 quantities, which are the length, the mass, and the time, are the most important quantities for us in this course. The length is the measure of the distance between 2 points, and you will see the scientific definition, modern definition, in the next page, which depend on the speed of light to measure the 1 meter, which is the scientific unit to measure the length. The meter is the unit to measure the length, not the feet. Also the mass, which is measured by kilogram, not by pound. And you can also find what is the most accurate definition for the mass in the next page, also in the next page in the book. And also the time, which is measured by the second, not hour, not minutes, not days, it is second, just second. So the main quantities for us is the length, the mass, the time, are measured by meter, kilogram, and seconds. Okay, the derived quantities, we have many derived quantities, not just 7 or 3 as we see for our course. For example, we have the area, the volume, speed, velocity, the density, the acceleration, the force, the energy. All of them are derived. What is the meaning of that derived? The meaning of that we can derive this quantity from a fundamental quantity, but we can't derive a fundamental quantity from any other fundamental quantity. For example, we can't derive the length from the mass or the time or any of these quantities, but we can derive the area from the length, which is meter by meter, which is square meter. We can measure the area of this surface, which is x multiplied by y. X is a length, y is a length. We can see that later in the examples. Also the volume. The volume is a third dimension to our area to be volume. In this case, for example, we have Z. So we have meter cubed. Meter cubed is equal to meter by meter by meter. So we can derive volume from the length. For example, the speed or the velocity, we will know what is the difference between them. It is meter per second. If we divide length over the time, it will be meter or over second. This will be equal the velocity or the speed. The density, the mass over the volume, kilogram over a derived quantity, kilogram over meter cubed, will give us the density, and so on. We can derive the derived quantity from a fundamental and or derived quantities. Also, we have another criteria to find or to know the sorry this is Fahrenheit, not Celsius. We have different systems of reading the units. We have English or British or US unit system, and we have the international system units or scientific international system units, or the French, which is the French system of units. Here in US, you measure the length using an inch or a foot or a mile, but this is not a scientific system of unit. This is the scientific international system of units. You measure the length by meter, and the derived quantities from, or the derived lengths from the fundamental quantity, which is the meter, is the kilometer or centimeters. This is the fundamental quantity or the scientific quantity. Also the mass, we measure the mass using the kilogram, and the gram is derived from a kilogram. But in English unit system, we use pound or ounce. For example, we measure the temperature using Fahrenheit in USA, but in scientific system of units, we measure it by using Kelvin degree. Sometimes we use centigrades or Celsius. Okay, we will see in different examples in the next section how to deal with these things. In the book, in page number 4, you will see in details the most accurate scientific definitions for the mass and the length and the time, depending on a universal constant, just like the speed of light, the Planck's constant, and the atomic properties for some atoms. This will give us accurate definition for these quantities, and these three quantities are the most important for us in this course. Thank you. Hi students, I will talk now about dimension analysis. The most important thing in this section is that I can't add different quantities to other. For example, this equation 4 is equal to 4, that is right in mathematics, but is wrong in physics, because the unit here is different than the unit here. The quantity here is different than this one. Also, the other equation, this one, 6 is equal to 4 plus 2. That's right, but it is not right in quantities. To make it right, I need to add 4 apples and minus 4 oranges. In this case, I can cancel these with these, and the total quantity will be apples. It is things like this, but we will see now in our examples. I will talk here now. If you look here, if I have a time equation, this left side will equal to the right side, and each term of these terms must have the same quantity type, which is time, and the dimension of this quantity is time. Also here, if I work with length, all the terms should be length. If I work, for example, with mass, all the terms should be mass. Take this numerical example. If I have 10 kilograms is equal to 3.8 kilograms, which is right, plus 200 grams, it is a mass, which is right, plus 1.5 A multiplied by M, which is volume. So A is hide inside it some different quantities than the volume. This is meter squared, cubed, I'm sorry, plus 9.92 pound. Pound is also a mass, which is right quantity. Now I need all of these quantities be in the same language, be in the same unit, which is kilogram, and also I need them to be in the same quantity and dimension. I will talk about this now. 200 grams, I will exchange them to be 0.2 kilograms. We will know later how to convert units. This is the first term. Now the second term, I need to put 1.5 as 1.5 kilogram, but I don't know A multiplied by M cubed. I need it to be in kilograms. So A M cubed is equal to kilogram. I can divide it both the sides on M cubed, on M cubed. In this case, A's dimensions is mass over volume, and the unit for A is kilogram for a cube meter. The volume in cube meter, which is, we know that area is equal to meter squared in units. If we take, this is the unit. If we take this is X and this is Y, then the area is equal to X multiplied by Y. X in meters, Y in meters, then the area in square meter, because area is equal to X in meters multiplied by Y in meters, which is equal to X multiplied by Y, and meter multiplied by meter, which is square meter. This is the area. If X equal to 2 and Y equal to 3, then it will be 6 square meter. Also the volume is equal, for example, this is the volume, X, Y, Z. The volume is equal to X, Y, and Z, and the unit will be cubed meter, and the dimension is length cubed. We will see that later. And then now we have A is equal to kilogram for over cube meter, and the last term 9.92 pound. We can convert and exchange pound to kilograms by multiplying by this number. We will see how to do that later. And I exchange now the number in the amount and the magnitude from pound to kilograms. So every 9.92 pounds is equal to 4.5 kilograms. Now I have all of the terms in kilograms. So 10 is equal to 3.8 plus 0.2, plus 1.5 plus 4.5, which is equal to 10. So the magnitude, which is the number in math, is equal on both sides. And the units, this one is kilogram, I'm sorry for that. The meter cubed here will cancel with this one, so it will be kilograms. This will not be it will not stay as in grams, it will be in kilograms. And from pound I exchange my unit to kilogram. So now the both sides has the same magnitude and the same unit. Now we need to look here about this table. We have these three quantities in physics, which are primary, and these are derivable. These are derived quantities. The length, the quantity of length, we can sample it by x, y, d, r for radius, s, and the unit is in meter, not in centimeter, not in yard, not in foot, and the dimension is length. So if we look at x or radius or a unit meter, it is a length, it is not a mass, it is not a time. Now the time mostly sampled by t or tau. The unit is second, not hour, not a day, not anything else. It is the main unit in SI units is second. The dimension is time. The mass can be sampled by capital or small mass. The main unit for it is a kilogram, not pound, not gram. The dimension is mass. And we need to know that if we use this bracket notation, that is meaning, the meaning of that is we are talking about the dimension. The derived quantities like velocity or speed can be sampled by v. The unit is meter per second, and the dimension is length over time. The acceleration can be sampled by a in lowercase. The unit is meter per square second. We will see that again later. And the dimension will be length over squared t, time. The force or the weight can be sampled by capital or small f. Weight can be sampled by W. The normal force can be sampled by N, capital N. The unit is kilogram meter per square second, which is equal to Newton unit. And the dimension is mass multiplied by length divided by squared time. Now I will start to solve these examples. I will take this equation. I don't know if this equation right or wrong physically or in physics. Okay, I have here x. X is a length, so this is length is equal to v is velocity. The dimension of velocity is length divided by time. Multiplied by a time dimension. In this case, I can cancel both of these terms because this over 1, and the final dimension is length. So length is equal to length, which is right, and I can expect that this form of this equation is right. Now I will look to the next one. Look, I just exchanged between v and x. Now velocity, the velocity dimension is length over time is equal to length for x, and the dimension of t is time. Look at that. I can cancel L from here and from here. This will give me 1 over t is equal to t over 1. By this process, I can multiply them, so I can find that 1 is equal to t squared. Look at this. This is a number. It is a dimensionless. It is not time, not length, not mass. It is just a number. It doesn't has any dimension. But the right hand side is square time. In this case, I has a dimension quantity on the right and dimensionless quantity on the left, which give me a wrong response or wrong answer. So this equation is wrong, cannot be true physically in physics. Okay, let me see now the third equation. The time x here, not the time, I'm sorry, x is length, x naught is also length. I can put subscript for any of these samples. It will not exchange thing, just it's a name. Plus x is also a length. Time is time. Plus a. Look here, a is acceleration. It's meter per square second. It is length over a length. I'm sorry. Over squared time. Is this equation works? I think no, because this term is length equal to length. This is good. Plus length multiplied by time. This is wrong. This is also wrong. So this equation cannot be true in physics. Let us see the last equation. This one is right, I know that. Look, x, we will find this equation and work with it later. X is a length equal to length plus v from here. Look at this table. Length divided by time multiplied by time plus half. It is just like this number. It is dimensionless. Where's the number? This one. It is dimensionless. So I will not put anything for any number. I will just use the samples. A is acceleration. A, length divided by time, which is squared in this case, multiplied by squared t or squared time. Look at this. I can cancel this by this because this is over 1 and this is over 1. Cancel this squared with this squared, and look at the final result. Length is equal to length plus the rest from this term is just length plus just length. In this case, length is equal to length. That's right. I can add length to length to length, but I cannot add length to length multiplied by time or mass or anything else. This equation can be true, and it is in physics. Also this one. But these are the second and the third are wrong. Okay. You can use and pick any equation from the book and try this technique using the dimension analysis. I will use this example from the book, page number 8. This asks me about some dimensions for A, B, C, and D. He tells me, or the question tells me, that X is a distance, V is velocity, A is acceleration, T is a time. I have four equations. A is equal to acceleration multiplied by time. B, I will work with this one at first. Okay, the dimensions of A is equal to the dimensions of the acceleration multiplied by the dimensions of the time, which is equal to, I can look at the table now. I am new in physics, I don't know a lot of these equations. I can cheat from any table when I am studying. Now, A, it is length over squared time multiplied by time. I am not checking here the equation is right or wrong, but I just looking for the dimension of the given sample. I can, this is over 1. Time here is to the power 1, so I can cancel this with the squared from the denominator. The final result will be length over time as a dimensions. As dimensions, not a dimensions. I'm sorry about bad English. So that dimension of A is length over time. This is the first one. What about the second given equation, which is B is equal to V over T? Okay, using the same way, the dimension of B is equal to the dimension of V divided by the dimension of T. This is equal to, the dimension of V is length over T divided by the dimension of T. I can use this over 1, which is equal to length over time multiplied by 1 over time, which is equal to length over squared time. Look at this one, length over time from the table, length over time, it is a velocity or speed. This is velocity. This is from the table is acceleration, which is acceleration. Okay, I can expect what is the sample denoted to. The third one now, C is equal to half x over squared t. Okay, the dimensions of C, look, is equal to the dimension of half multiplied by the dimensions of x divided by the dimensions of t squared. The dimensions of half is 1, not 0. If I put it 0, all of them will be 0. It is dimensionless. Multiplied by the dimension of x, which is length, divided by t squared. There's no meaning if the squared is inside or outside the bracket. So the final, now we have that dimensions is length over t squared, which is again like this, which is acceleration. Okay, the third one, D, is equal to dimensions of 2 multiplied by the dimensions of the acceleration and the dimensions of x, which is equal to dimensionless. The dimensions of A is length over squared t multiplied by the dimensions of x, which is length, over 1. Now I don't know why I'm changing the color, but I can multiply them in this way: length squared over t squared, which is equal also to length over t, all of them are squared. Length over t is a velocity. In this case, this is squared velocity. Please try many examples by yourself. If you have any questions, just send them to me, and thank you. Hi students, I will talk now about units conversion. Okay, we need to deal with the international system of units. I have the base units, the main 7 base units. The first one is the length, which has a sample m, and we need and we measure it in meters. Yes, this is the sample of the unit. The mass measured in kilograms. The time is measured in seconds. Electric currents in amperes. The temperature measured in Kelvin. The amount of substance in mole. The luminous in candela. And we have many derived units. For example, frequency, the force, the pressure, energy, power, velocity, acceleration, and their units are derived from these main units. Also, we have the prefix like kilo, mega, giga, tera. Also centi, where is centi? This is centi, milli, micro, nano, pico, and each one of them has its sample. Also the numerical value for it in decimal notation and in scientific notation. For example, this is giga, which means billion. 1 billion is a giga, which is 10 to 9. We talked previously about the scientific notation. Also nano or pico, which is 10 to minus 12. We can see this. This is the decimal point, and we have 12 steps with moving for this decimal point. Also, we have 10 to minus 15, which is femto. Okay, we will talk now about units conversion. For example, in SI units or metric units, we will talk about these units in meter, kilogram, second, but in customary or in US unit system, we deal here in this country, for example, and in Britain, using inches. Each inch is equal to 2.54 centimeters. We can see here, this is a scale. This is the centimeter from here to here, and this is the inch. By the way, when we measure something, we need to look perpendicularly to the measurement tool. This is the inch, and this is centimeter. This is about 2.54 centimeters. The foot, I think the foot is 12 inches. This is 12 inches. From here. Yes. This 12 inches. This is a foot. 1 foot. It is equally almost to 30 centimeters. It is about 30.48 centimeters. Look to this scale is 30 centimeters. 30 centimeters and 12 inches. And so on. 1 yard is about 0.214 meter. It's almost 90 centimeters or 91 centimeters. 1 mile is equal to 1.6 kilometers. And we can use this ratio. If I take this 10 centimeters, if I equivalent them to 1 kilometer, then if I need to draw a mile, it is 1.6, almost 16 centimeters is equal to 1.6 kilometer as this line, which is equal to 1 mile. So this scale of drawing I took here, 10 centimeters denoted to 1 kilometer. If I need to draw a kilometer on a piece of paper, I choose each centimeter is equal to 100 meter. 10 centimeters equal to kilometers, which is 1,000 meter. So 16 centimeters equal to 600 or 1600 meters, which is almost equal to 1 mile. This is 1 mile is almost 1.6 kilometers. 1 ounce is equal to 28.35 grams, and so on. What if I need to convert, for example, 3 inches to centimeters? I will draw them now. From here to here, 3 inches I need to measure them. I can exchange them to centimeters by 2 ways. I can measure them or calculate or compute. Okay, how to compute that? I know that, look here, 3 inches is equal to 3. 3 is equal to 3, but inch, this is 1 inch. 1 inch is equal to, I substitute this value, which is 2.54 centimeter. This value is 1 inch. In this case, I exchange from inches to centimeters. Now I will multiply the numerical values together. 3 multiplied by 2.44, which is equal to 7.62, the value of in centimeters. Okay, there is another way in I can use it. I can also multiply by 1. How can I multiply by 1? Okay, 1 inch over 2.54 centimeters is equal to 1, because these two values are the same. Also, this value I can exchange it like this: 2.54 centimeters over 1 inch. They are the same, they are equal to 1. Now, if I need to exchange the value, look here, 3 inches. If I multiply it by 1, it is okay with me, okay, or to me, which is equal to 3 inches. I need the final value in centimeters, so I need to multiply it in the exchange value, maybe this one or this one. I will take this one. Look, why 2.54 centimeters over 1 inch. In this case, I can cancel inches from both sides, and 1 is 1. I can then find 3 multiplied by 2.54, just like what I achieve here. So this will be equal to 7.62 centimeters. Just I have this value as a unit. So my 3 inches are 7.6 centimeters. Now I will measure. This is the first value. Give me by computing 7.62. I will measure now. This is an experiment, what I'm doing now, which is the measurement from here to here. It is 1, 2, this is the beginning. Be careful. 1, 2, 3, 4, 5, 6, 7, and I now count the millimeters, the small lines here. 1, 2, 1, 2, 3, 4, 5, and something. It's about, in measurement, 6. Yes, it's about 7.6 millimeters, because rather the resolution of my tool is not good enough to measure this value, because this value in hundreds, I can measure just in tens in this tool. So in measurement I have an error here because of my tool, which is two difference from the computed value. Now I will move. This is this sheet is from the book. It contains conversion factors between different units. For example, this is the mass. I can convert between, for the mass, between the kilograms and the grams. Each 1 kilogram is equal to 10 to 3, which means 1000 gram. Length. If I need to exchange 1 inch, it is 2.54 centimeters and equal to 2.54 multiplied by 10 to minus 2 meters. If I need to convert it to meter. Okay, also 1 centimeter is 10 to minus 2 because meter. Because of that, I use it here. So the conversion factor, which I use it here in this example. So I have this conversion factor if I need to change from centimeter to inches, and this if I need to exchange from inch to centimeter. I will take this example again now. In this way, what if I have 7.62 centimeters and I need to write it in inches? Okay, I will take it like this, 2 centimeter, and I will multiply it by 1. 1 from here, it is in centimeters, I need it in inches. So I will choose this one because I have the centimeters in the denominator. Okay, this is 2.54 centimeters from above inches. Okay, look, it is easy now. I can cancel centimeters and I will have this value, 7.62 over 1 multiplied by 1 over 254, which is equal to 7.62 divided by 2.54, and I will use the calculator again. It is the inverse of our first process. No, 7.62 divided by 2.54. It is 3 inches, which is the same first original value. We can convert between inches and centimeters and vice versa. Okay. Also, I can exchange forces. The force, the unit of force is 1 Newton. The pound is a weight. Also pressure, energy, but the most important thing to us is the mass in our course, and the length, sometimes the force, and that's it. What we need to use is just the conversion factor, which is the number connect between two units. If I have for example meter and feet or foot, there's a number between two of them. This number is the conversion factor, whereas in meters and foot, look, each 1 meter is equal to 3.28 foot. This is the conversion factor between the two values, the two units. Now we will take many examples. Okay, the first one, if I have 120 meters, okay, each 1 meter from here 1 is equal to, I didn't put anything here, I can use this conversion factor, is equal to 1 meter over 3.281 foot, also is equal to 3.28 foot divided by 1 meter. Now I need to exchange from meters to foot. I will pick one of these values. They are the same, but I need to cancel the unit from the first one to achieve the last unit. I will choose this one. Okay, this way I will write 120 meters and then multiply it by this value, which is 3.28 foot over 1 meter. Easily now I can cancel the units and have two values, the numerical values and the unit, and that's it. Look at this, 120 multiplied by 3.28. Is that right? Yes. Also I have 1 here and here and here, this one. Okay, and this is 1, which is equal to 393.72 foot. Now I complete it. So each 120 is equal to 393.72. Okay, what if I need to change masses now? Exchange masses or convert masses. 215 pound. I need to convert it to kilograms. Okay, I know that 1 is equal, the conversion factor is each 1 kilogram is equal to 2.2, no, wait, the mass is 2.25 pound. Also 2.25 pounds is equal over 1 kilogram. Okay, I will change from pounds to kilograms, so I need to cancel this value. I am looking for the unit, this unit, pound units, in the denominator, which is the first one. Okay, I just need to multiply by 1. 215 pounds, multiply it by 1 kilogram over 2.25 pounds. Easily now I can cancel the pounds and I have this value, 215 over 1 multiplied by 1 over 2.25 kilograms in the denominator. Okay, which is equal to 215 divided by 2.25 kilograms. Now 215 divided by 2.25 5, not 8, which is equal to 9.5, no, sorry, 95.55 and so on kilograms. This is the mass of some some people in pounds and kilograms. Now, what if I need to convert a day to minute, or foot to kilometers, or from kilometer per hour to meter per second, or from mile per hour to meter per minute? I can do that for any one of these values. I will do what I need, just the conversion factor to use it. Okay, I will try to do this one. Okay, 80 miles per hour. Now I will multiply. I need the conversion factor for miles and for hours to minutes. I know that each hour is 60 minutes. Okay, if I need to convert from hour to minutes, from miles to meters. Okay, each 1 mile, or I can put the conversion factor by this way. 1 is equal to 1 mile over from here. Where's the length? This is the length. Where's mile? This is mile, which is equal to 1609 meters. 1609 meters, also equal to 1609 meters over 1 mile. I can use this to change this value, just the unit, leave the numerical value as is. Also, hours, 1 hour over 60 minutes is equal to 1. Also, 60 minutes over 1 hour is equal to 1. Okay, I will do it here. Look at that. I have 80 miles per hour. Simply I will multiply by the value which cancel the miles, which is this one here, 1609 meters divided by 1 mile. This is in the denominator, like this. And here I will multiply by the value which cancels the hours, which is this value, which is 1, which is 60 minutes over 1 hour. Now I have 2 processes, one in the numerator and the second in the denominator. Okay, I will cancel miles with miles and hour with hour, and look what I have. I have meters per minute, and the numerical values, I have 80 and I have 1690. Look, be careful when you write the division lines. There is a main big one and a minor process here also. I need to keep the line. I know which one is the right one. I will tell you later. There is sometimes will be errors when the student write it in wrong way. Okay, which is equal to 80 multiplied by 1609 over 1 multiplied by 1. Wow, I'll complete it here. multiplied by 1 over 60. Okay, this value is equal to this is which is equal to 80 multiplied by 169 over 60, which is equal to, where's the calculator? This is it. You can see the calculator. 80 multiplied by 1609 over 60. Yes, the answer is 2145.3 meters per minute. Is that right? Meters per minute. Meters per minute. That's mean if I am in the car and this car moving 80 miles per hour, then I move 2145.3 and so on meters per minute, and this equal to, if I move the decimal point 3 steps in this way, it will be 2.1453, which will be in kilometers. I have 2 kilometers point 1453. I see how to exchange the units if I have derived unit, or if I have main units or base units. You can now exchange this one, this one, and this one. What you need to know, just the conversion factor, which is equal unit over unit with some value factor, and both of them divided over each other like this are equal to 1. Okay, I have this example from page number 11, and I have also these from the problems page number 17. I'll try to do this one with you, and I will leave this for you to do it. It will be easy. Now, to convert length 6 foot to its equivalent in meters. Okay, I have 6 foot. I will need it in meters. Okay, I need to know the conversion factor. In this way, 1 is equal to, if I need to multiply it in meters, it's new to me. I am not good enough in carrying these values. I will have this paper and any other sheet to cheat from it to solve my problems. Okay, where is meter in foot? It is 1 meter over 3.281 foot, which is also equal to 3.281 foot over 1 meter. I will exchange from foot to meters, so I need to cancel the foots. I will use this value. Okay, I will use this one and compute the length in meters. The question asks us which is the factor I should use. Is it A, 1 mile over 5,280 foot? No, I don't need to convert from foot to mile to meters. So I am looking foot to meters. Yes, this is a factor, but the meters in the denominator, and in this way, if I need to exchange from meters to foot, I will use this value or this factor. I will not use it now, and I will not use this. This one, the foot is in the denominator. That's right, I need to cancel it. But if I look, the factor here is wrong because 3.281 is with foot, not with meter, like this. This D is the right one. Look, this is D. Also 1 meter is equal to 3.81 foot, not 3.281 meter is equal to 1 foot. 1 foot is short. 1 meter is about more than 3 foot. So be careful about that. Okay. Also, I can solve, and you can solve this problem. Try that. This question, for example, is for a coffin. I think its length is 2.5. And width and height is 1.5. So I have it like this. I'm sorry about this. I'm good in drawing, not bad. Okay. If I calculate it, the cubits in foot or in inches, because 1 cubit, given that a cubit equivalent to 17.7 inches, so each 1 cubit is equal to or equivalent to 17.7 inches. Okay, my conversion value is equal to 1 cubit is equal over 17.7 inches, also 17.7 inches over 1 cubit. This one is in cubit. This unit is a cubit. This unit is a cubit. I can compute the size of this, the volume of this in a cubit. Just I multiply it because if I have x, y, and z, the size will be, or the volume is equal to x, y, and z, which is equal to 2.5, 1.5, 1.5, which is equal to, look, this is in a cubit, this is in a cubit, this is in a cubit unit. Okay, 2.5, 1.5, 1.5. The answer is equal to 5.625 cubit multiplied by each other 3 times. It will be cubit. I need to exchange it to inches. Okay, I will pick the first length, which is 2.5 cubit. I need to multiply it by the exchange value from here. I need to cancel this value, this unit. I will use this. So 17.7 inches over 1 cubit. That unit will cancel, so I will have 2.5 multiplied by 17.7. okay, 2.5 multiplied 2.5, I'm sorry, but 17.7, and this is equal to 44.25 inches. Okay, also 1.5 cubit, I need to multiply it by 17 the same way, 1 cubit
this will cancel. So this, sorry, 1.5, it's equal to 26.55 inches. Okay, I can compute the volume in inches. Now the volume is equal to x, y, z in inches. X is the same, this value in inches, which is equal to 44.25 multiplied by 26.55, also 26.55, but this value in inches, which is equal to, okay, 44.25 multiplied by 26.55 multiplied by 26.55, which is equal to big value in inches, because the inch is smaller than the cubit. Okay, 91.935, all of it, 625, and inches cubed, or cubed inches, because it is a volume. I can round this value if I need to round it to 2 decimal points. From here I need to cancel these digits by rounding, not by trunking. Okay, this value is 5. If this value is 5 or more, I will approximate it to 1 and add it to the value or the digit which is before it, which is, and my final value is equal to this value cubed inches. This is the volume. This is question number 21. You can do any other question by using the same way, and you need to use this method in the lab experiment. Thank you. Hi students, now I will talk about important thing in physics. I will talk about scientific notations. What is the scientific notations? We have many numbers in physics that need us to deal with it using the scientific notation. Now we know that if we have a number is 10, this 10 is equal to 10 to 1, and 10 to 0 is equal to 1. 10 squared is equal to 100, and so on. If we have 10 to 6 is equal to 1,000,000. So we will see how to write some of these numbers. If we see this number 5, 2, 3, 1, 4, this is not the decimal point, this is just a comma here. If we need to write it in a scientific notation, we need to use just one figure in the left of the decimal point. The decimal point in this case is here, and all of the other digits here is are zeros. So the way to use the scientific notation in this case, we need to use just one figure. So we need to move the decimal point to this place. In this case, we will move it 4 steps: 1, 2, 3, and 4. If we move that decimal point to the left, then we need to multiply by 10 to the plus value, which is plus 4, because we move it 4 steps. Now we have that final number 5.2314 multiplied by 10 to plus 4. This is a scientific notation of 52,314. We use the decimal point after the first digit. Also, we have in this case our decimal number is 3.2. It is ready just one digit on the left of the decimal point. We can write it multiplied by 1, but 1 is 10 to 0 because we move the decimal point 0 step, neither nor right or nor left. This case we don't have, this is the decimal point, we don't have here any digit. The first digit is 4. We need to move this decimal point to right of this digit. We need to move it 1 step, 2 steps, 3 steps, 4, 5 steps, but we move it to the right. When we move it to the left, we multiplied by 10 to plus number of steps. Now we move it to right. In this case, we want to multiply it by 10 to minus number of steps, which is 5. In this case, we have the number 4.28 multiplied by 10 to minus 5. Also, here we have this long number. We have not many, just 6 zeros, and this is a decimal point in this place. We will move it 6 steps and moreover 2 steps to have the number 6.02, and all of the rest are zeros. So we need to move it 8 steps to the left. Then we will multiply by 10 to plus 8 in this case, and our number is 6.02 multiplied by 10 to plus 8. We have different examples here are the same. We move the decimal point to the left 8 steps, then we will multiply by 10 to plus, and if we multiply it, we move the decimal point, look here, if we need to convert the scientific notation to decimal notation. Look here, I will do this here. 5.6 multiplied by 10 to 4 plus 4. This is equal to 5.6 multiplied by 10 to 4 is 10,000, which is equal to 5. We now can move the decimal point to right 4 steps. I'm sorry. So the first step will be here. The second step we will have zeros. So second step, third step here, and fourth step here. So our number will be 5600, and this is the decimal point because we move the decimal point 4 steps to right. And the same, if we have this number 3/1000, which is equal to 3/10 to 3. It is easy to understand this. Now if I need to move the 10 from the denominator to numerator, it will be like this: 3 multiplied by 10 to minus 3. So 10 to minus 3 is equal to 1 over 1000, or equal to 1 over 10 to 3, which is 1 over 1000, like this one. And I can move the decimal point from the right of 1 to the left of 1. If I use the minus sign from here, this is 1. I will move one step. I have zeros on the left of the one. One step, two steps, three steps. The decimal point will be here. So my final number will be 0.001. This is 1,000, which is equal to 1 multiplied by 10 to minus 3, or equal to 1 over 1,000. You will see this is the second sheet. You will see now here many scientific notations from 10 to minus 6 to 10 to plus 12. 10 to plus 12 means I have 12 zeros. 10 to minus 3, it is the same as our example. Now, in physics, we have a huge amounts of quantities. For example, we have Earth's mass. It is, I don't know how many zeros, 3, 6, 9, 12, 15, 18, 20, and then I have many steps here. What is it logical to, if I need to calculate anything, to write this number over and over each time, or I need to use the scientific notation to make it easy to me? So the scientific notation make me write it like this, in this way: 5.9736. That's because the scientific notation make me to put a decimal point to the right of just one digit. Now, how many steps I move the decimal point? Originally, I have this. This is the place of the decimal point. These are commas, not for thousands, not a decimal point. I move it. How many steps? Let us count them. 1, 2, 3, 6, 9 steps to here. 12, 15, 18, 21, 24. So multiplied by 10, because I moved the decimal point to the left, it is plus 24 steps, or 24 zeros. So each time I can write the mass of Earth is 5.9 multiplied by 10 to plus 14 kilograms. Be careful that 1 ton is equal to 1,000 kilogram, which is equal to 10 to 3 kilograms. So the Earth is very heavy. The Sun, the magnitude, look, magnitude of the value of the Sun's mass is about 10 to 13. This is the magnitude, and this is the magnitude. Maybe I can approximate this number to 6 or 5.5. It is okay, but the most important number to me is this magnitude. It is it makes the difference in my calculation. So mass of Earth is equal to 5.9736 multiplied by 10 to 24 in a plus sign. Now, what is the mass of the electron? This is the mass. It is 9.1 something divided over this long number of zeros. this number of zeros, look, let us count them. 1 4 1 4 7 10, yes, 16 22, yeah, 28 31 31 zeros. But when we're in the denominator, that's mean I have 9.1. I can approximate everything. The most important thing is the magnitude divided by 10 to 31. This is number 10 to 31 because I have 31 zeros. This is equal also to 9.1. I can put this in the denominator, which is equal to 10 to minus 31 kilograms. So the mass of electron is 9.1 multiplied by 10 to minus 31 kilograms. It is very small number. The mass of a proton or a neutron in magnitude of 10 to minus 27. So the proton or the neutron are heavier than the electron about 1,000 times or 2,000 times. By the same way, we can find these numbers and solve them in scientific notation. Write them. I'll try to solve one of these or two of these numbers. Let me take this one. 3 to minus 9, which is equal to, it is not 10, it is 1. It is over 1. I can put it in this way, 1 over 3 to 9 plus 9, because I move it to denominator. Okay, I will use my calculator to find how much 3 to 9 is equal to 19,683, which is equal to 1 over how much? 683. Okay, how much 3 to minus 9? Look, it is ready in scientific notation, which is equal to 5.08, and I can approximate everything else, multiplied by 10 to minus 5. By the way, I used to write it like this, 5.08 e minus 5 in computer notations. It's okay to write it like this. E to 15 is equal to 10 to plus 15, and so on. Also the same, I can solve for 2 to 12. 2 to 12 is equal to 4,096. Sorry about that. 4,096. This is the decimal point is here, and all of the else here are zeros. I need to write it in scientific notation. I will move the decimal point 3 steps to have it like this, 4.096 multiplied by 10 to, I move it to left, then it will be plus 3 steps. That's it. You can do it for all of these numbers. Try any number. Thank you.